Hey guys, it's time for another lesson brought to you by Mrs. Robinson. So today we are going to talk about exponential function graphs and what pieces make them the way that they look and the elements, what they mean in word problems, why we have exponential graphs at all. So um, it's a good way to organize your data, and it's a good time for us to have this lesson because viruses grow and spread exponentially, and that's what our task is going to be about. When we meet on Wednesday, we'll talk more about that. I already showed you one graph in the last video, and now we're going to talk about the pieces of the graphs. Okay, so here's the function. And I'm going to try to do as many of these as equations so you can see them as they should be as much as possible. So y equals a. Now I'm going to make the times as a dot because I don't want you to get confused with x, and the star doesn't look very good. So it's times b to the x as the exponent. That is what the indicator is. If x is an exponent in your function, you have an exponential function. I'm going to write it again up here and talk a little more about it. Exponential functions are defined by an equation in the form of if it's got an x in the exponent. I'm going to write it again as equation y equals a times b to the x. And then I'm going to talk a little more about this because I want to make sure that you understand that a is not raised to that exponent. A is out front like a coefficient. So I'm going to write a couple of things about a right here. Let's see if that works. A is a coefficient, and a, that coefficient, is the y-intercept. So those are two very important things. And for our purposes to start, we're going to start with, so if you don't see one, then a equals 1. Don't forget, when it's by itself like this and you don't see one like in number 1 here, there is no number in front of the 2. The 2 is the b is for base, which I'm going to write in a second. But there is no a there, no number there, but there is always a 1. If not there. So how about that? All right. So the first kind of function, we'll talk about the b's now, and I'm going to actually write that down here, that b, jump down, b is the base. X is the exponent. I mean, that's pretty obvious, but you should know what the pieces are called when I talk about them. I'm going to talk about the base a lot, I'm going to talk about the exponent a lot, and I'm going to talk about the coefficient or the intercept. I'm going to ask you what it is and stuff like that. So it's good to have these terms written down to help you remember what they are. Okay, so here we are talking about if b, the base, this part right here, not the a, but the b, is greater than 1. Anything greater than 1, 1.5, 2, 10, whatever. If it's greater than 1, then we have, then your exponential function is exponential growth. So that's pretty easy to figure out that it is exponential growth, and I'm actually going to go ahead and make that red for you so you can see that that is part of this definition and not part of the above. And if it is exponential growth, then it is increasing. I'm trying to format this so it looks a little better. I'm going to try to go as quickly as possible. Okay, now if b is less than 1, and that really means, I'm going to write that here, b is a fraction. Not an improper fraction, though. This is important. This is something that people mix up all the time because they'll see if it's a fraction, it's going to be decay, but an improper fraction is greater than 1. That means it's like 5 over 2 or 8 over 3 or something like that. Improper fractions are greater than 1 and they will be growth. But these less than 1, when they're fractions less than 1, they will, let me see if I can get this to work. Okay, that's fine. Fractions less than 1 are exponential decay. And I had trouble moving this before. Let's just do this first. It's exponential decay. I'm going to try really hard to move this. That's pretty good. Okay, so exponential decay if it's a fraction. And that obviously means that it's decreasing. And we're going to show you examples of these so that you can see what we're talking about. All right. Asymptotes we're going to save for later after we graph a couple of things here. So we're going to scoot down here to number 1. And we're going to go ahead and make a table so you can see what this graph looks like and what the pieces are, and then we'll talk about the asymptotes. So I'm going to come here and insert a little table here. So get ready to draw a table if I can get this going. So I'm going to insert a table, and I'm going to have it have 3 columns to start, because having 3 columns to start will help us understand where these numbers are coming from. So this second number, I am going to put the function, which is 2 to the x. So I think this is right, 2. No, I don't know what it's doing. Hold on a second. Let me get this. I don't want that. I want center. Well, it would be anyway. And I want to insert an equation. There we go. Okay. So our equation is 2 to the x. And so what we are going to be doing is plugging in numbers for x into this equation. Then we are going to go to y to get our result. So we get an x, y, we get points, we can plot the points, no problem. Anytime you have any kind of graph that's a y equals and you can plug an x into it, you can plot the function. No matter what it is, if you don't have your graphing calculator, then you can do it without a graphing calculator. If you do, you can definitely use it for these problems, but you're still going to have to figure out what these things are. So that's why I'm going through this. Okay. The numbers you want to use are always going to be -2, -1, 0, 1, and 2. We're going to use those every time. These are the best numbers to use because they are small and they are easy to work with exponents. When it gets bigger, it gets crazy, which I think I showed you in the last video. And that growth, those exponential graphs, they get high really fast. So this one will show you both sides of what the graph looks like. So let me see if I can do this right here. Oh, good. And I'm going to do the same thing here. Okay. So what I'm going to do in this box right here is I'm going to put that -2 in for x. That means I'm going to have to insert an equation again so you can see it better. So instead of being like y equals 2 times x or something, it's going to be the exponent. So this means 2 to the -2. There you go. You can see it that way. And this equals, whenever you have, remember we did negative exponents mean that you have to flip it. So this equals 1 over 2, and then I have to put the exponent on it to the -2. So this is real, oh, it's positive now. My bad. So when you flip it, it becomes positive, remember? So 2 to the negative 2 equals 1 over 2 squared. And then 1 over 2 squared, so we're going to put that over here, is 1/4, which equals 0.25. Look, I put equals and it just gave it to me. That was nice. Okay, so 1 over 4 equals 0.25. We're going to do a couple more, and I'm just going to go ahead and fill in this table and not talk as much. But you can see, and then you'll see what this graph looks like once we graph it. So I'm going to plug these in. So that is, okay, 2 to the negative 1, and that equals 1 over 2 to the positive 1. And I'm going to go ahead and put, even though you don't need it, I'm going to put it to the positive 1. And so this just equals 1/2, which equals 0.5. And then we come down, 2 to the 0. I know you guys remember what 2 to the 0 is. 2 to the 0 always equals what, people? It equals 1 every time. Anything to the 0 power. Oh, and we're running out of room. All right, so 2, keep doing this so you can see it. 2 to the 1 equals 2, and 2 squared equals 4. Okay, so we've got some points here. And now I'm going to attempt to draw them. So let me get to that screen and make sure that I can do that. And I'm going to get a little thicker here. So I am going to draw negative 2 to the 1/4. Now I'm not going to put points because it always gives me trouble when I put points. I mean, it's going to be a little line. So negative 2 to the 1/4. I wonder if I can zoom in on this a little bit. I don't know if that's going to mess up my screen. Oh, it might be all right. Okay, so here's our problem, and I'm going to put negative 2 to the 1/4. That's about right there. Then we got negative 2, or negative 1 to the 1/2. Well, that's not much farther up, is it? And then we have 0, 1, that's just right there. And then we have 1, 2, which is right there. And then we have 2, 4. 2, 1, 2, 3, 4. See, I told you it doesn't like those. It doesn't like the little spots. 2, 1, 2, 3, 4. Oh, now it's not doing it again. Okay. Let me make sure my pen's on. Okay, it is, I think. Okay, there we go. 1 and then 0, 1, 1, 2, and 2, 4. Okay, so I'm going to draw this and show you the gist of this graph. Okay, so here we go. That's what the graph looks like. And I'm going to go back to the text. And good. Okay, so the big deal here is, actually I want to show you what this was, a growth. I almost forgot that. This is a growth. You can see it's going up. B is greater than, so let's say B equals 2. And B is greater than 1, so it is a growth. Okay, then we've got, we'll talk about domain and range a little bit later. We just want to get the pieces down first. We have done this, and I'm going to say, since I have an arrow on both sides, I'm going to go ahead and tell you, an arrow on both sides means domain is all reals. We know that. And that the range, now this is the tricky part. See, I don't know if you can tell this, but when our fractions are getting closer and closer to 0, so this graph is actually going to keep getting closer and closer and closer and closer to 0, but it is never going to touch 0. So that means that our range is y is greater than 0. And that's all we're going to put for now. Now, before I said that the y-intercept was a. Well, in our case, a equals 1. Just to remind you that it is there. The coefficient a is there, but it's 1. So that is our y-intercept. And you can see that was on our graph. So, and I'm going to put it as a point, 0, 1. And now we're going to talk about the asymptotes. So I'm going to switch back up here to talk about what an asymptote is. I'm going to type that in. Okay, fine. Okay, so an asymptote is, it's like a boundary line. And I'm going to go ahead and put a boundary line that the graph touches, or sorry, that the graph approaches, but doesn't touch. Okay, so that, and we're going to make that highlighted. And here in a minute. That is an important thing. So we'll just leave that like that. Okay, so that is what an asymptote is. Now let me show you what it looks like. So now I'm going to switch back over to drawing, and I'm going to use a different color. Blue, fine. Okay, so this is the asymptote. And I kind of try to make it a dotted line, but you know, whatever. So that is the asymptote for these graphs. Most of the time, if a equals 1, because the y-intercept is going to determine where it is. And so this asymptote for this particular graph is y equals 0. Oh, no, it did it again. Why are you doing that? I'm doing this. Oh, because I feel, okay. So it is y equals 0. So notice all of these things that we're talking about, the range, the y-intercept, and the y equals 0 asymptote, those are all having to do with y. And that's because x is in the exponent, and that's all we're going to talk about. So this is the case for all of these things. It's all going to have to do with y. That is the answer for all these functions. All right, let's go ahead and go to the next one. So you can see. So first we're going to talk about what this is, and then we'll make our table. We're going to fill in some of these things first. So first I'm going to say that b equals 1/4 and a equals 1. It's always good to know what a and b are because you're going to have to use them. And since b is 1/4, it is a decay. And so we're going to talk about this a little more after we do our table. And we're not going to have to do a table every time because I know that you guys have graphing calculators. Some of you do. You can also use Desmos to look at these graphs and fill in the tables and fill in the graph. I'm fine with that. But you do have to know what these pieces are from the graph. So that's why I keep doing this. But I am going to do one more table. So let me get to this, and I'm going to put it right here. Okay, fine. We'll see what that does. Insert another table. All right, that's good. And so we have our x, and we have our function, which is, and they put parentheses around this, which is a very good idea. 1/4. Well, that didn't work out so well, but whatever. To the x. Oh, there we go. Okay, so there's our function, and then our y. So let me go back here and make sure this is centered so that when we add, whoops. Okay, so we're going to do the same numbers. So I'm going to start with -2. And I'm going to show you what it does as we go through this. So All right, y equals 1/4 to the -2. And you know that that is going to flip. That is going to flip it. And I'm actually going to put that in this one for the interest of room. Oh, we don't put y equals in this. That's not bad. We don't need that. There we go. That's better. As I said, we're going to continue with -1. And we are going to add that equation to the -1. Looks good. And that equals, well, I'll show you. Just to make sure you guys understand, because I know some people need to see it. So it's like 4 to the 1 when you flip it, and that equals 4. And then we're going to go to the next with the 0. See how nice and easy 0 is. 1/4 to the 0. And then it equals 1 because everything equals 1. That is to the 0 power. Okay, and we're going to do just, I don't know if we have room. We'll do as many. We'll do one more at least. And we'll probably do 2 more because once. So this will be 1/4 to the 1. It's these 1/4 that are huge. 1/4 to the 1 equals 1/4. And then 2. Last one. 1/4 squared. And that's 1/4 squared now. Distribute the 2. Now, I haven't talked about that because we've been having these negatives and they flipped it. But when you have a fraction, you have to remember this is 1 to the 1 and 4 to the 1, and that's why it's 1/4. 1 squared is still 1 over 4 squared, which is 16. Now let's see if they do this for us. Whee! Look at that. They gave us the decimal. So that is a very small decimal. And this is what's going to happen. You're going to see this when we graph it. So let's go ahead and graph it. And I don't have squared on there. I can't do 4 squared, but I'm going to do as high as I can, which is 10. So that's where I'm going to start. And I'm going to go ahead and do it in blue since I started in blue over there. So -2 starts at 16, way up there. Okay, like that, somewhere way up there. That's where -2 starts. -1 starts at 4. -1, 1, 2, 3, 4. Remember, I'm just doing little lines here. 0 is still 1. So that A is still the y-intercept, and it's still 1. Remember, 0 is going to be 1 no matter what, unless it's a different A. So, and then 1 is at 1/4, which is right a little there. And then 2 is at 1/16, which is even closer to 0. And so that's what happens to this graph. I have it on 0, but it's not supposed to. It doesn't actually touch it. All right, let's go ahead and figure out. The domain is going to be the same. I got arrows both ways. Arrows both ways. Domain's always going to be all reals. So all of these graphs, domain is all reals. The range is still above where it's approaching, above the asymptote. So that's how you're going to know where your range is. The range is above 0. Now the asymptote is going to change in the next couple of ones. But for now, if A is 1 and you have nothing else moving it around, its y is greater than 0. Then the y-intercept, like we said, the y-intercept, and you can find it in your graph. Wherever x is 0, you can find it in your table. So that is 0, 1. And then the asymptote, which I am now going to draw in red, like we said before, it's 0. Y equals 0. So that graph is approaching that asymptote. It's not supposed to be touching it, but that's my drawing. So, and I have to tell you, on your graphing calculators, they don't draw asymptotes very well. All right, let's do a couple more examples.